Hello and welcome to Mechanical Y. Here I have a typical household smoke detector. These detectors sound an alarm when they sense a certain amount of smoke in the air, typically indicating that there is a fire somewhere nearby, which allows people to take action before the fire becomes dangerous or out of control. These are quite common and extremely effective life-saving devices. But how do they work? How does the sensor inside this device actually determine if there is smoke in the air? There are two common types of sensors used in the home. The first is a photo-detecting or optical sensor. This is a very simple system where a small light inside this device actually shines on a light-sensitive sensor. Under normal operating conditions, this sensor gives off a constant signal because the light is not being obscured by clean air. In the presence of smoke, the light is obscured and the signal from the sensor changes, and this sends a signal to sound the alarm. The second type of smoke detecting sensor used is an ionizing sensor, like the one used in this particular device. These actually contain a very small amount of radioactive material, americium-241 in this case, but this is enough to ionize a small amount of air between two electrodes. These electrodes read the resistance of the air and compare it to a reference. Under normal operating conditions, this resistance should be constant and equal to the reference. However, in the presence of smoke, the resistance between the electrodes changes, and this causes the alarm to sound. Though both smoke detecting systems perform similarly well, each does have an advantage. Photo detecting sensors, for instance, can better identify slow-moving fires, burning embers, and dark-colored smoke, while ionizing sensors like this one can actually detect fast-moving fires and lighter-colored smoke. Some smoke detectors do, however, use both systems. And before you get too worried, the amount of radioactive material inside a smoke detector like this one is very small and quite safe to use inside the home. However, some of you will recall the story of David Hahn, the Boy Scout who in 1994 built a primitive reactor in his home using material from smoke detectors like these. However, this required the material of many smoke detectors, and it also required the use of expert knowledge. Furthermore, David Hahn really had to go out of his way to accomplish this. He even lied and pretended to be a college professor in order to obtain enough material for his experiments. And this isn't something that the average homeowner really needs to worry about with smoke detectors like this. It should also be noted that smoke detectors are not fire detectors. Fire detectors operate under a different principle, usually sensing the heat given off by flames. Some automatic sprinklers work in this way, and they include a glass bulb that plugs a nozzle connected to pressurized water. The bulb is filled with a liquid that expands in the presence of heat and shatters when the heat gets too high. When the bulb breaks, the plug is released and the nozzle allows water to shoot out, thus helping extinguish the fire. But a system like that would not be useful in detecting smoke. Smoke not only strongly suggests the presence of fire, but it can also indicate smoldering embers which may not be giving off enough heat to set off a fire detector. And these can still be dangerous if left unchecked. In addition to detecting smoke, many detectors, like this one, also detect carbon monoxide. Carbon monoxide is an odorless and colorless gas that can be fatal if too much of it is inhaled. It occurs when there is incomplete combustion due to insufficient oxygen. There are many different ways to detect carbon monoxide, but this particular sensor uses an electrochemical process. Here, two electrodes form what is effectively a mini fuel cell that is specifically tuned to react with carbon monoxide. In the presence of carbon monoxide, the current that this fuel cell gives off changes, and this sends a signal to sound an alarm. Carbon monoxide sensors, however, do not detect smoke. This device actually has two distinct sensors in it, one for detecting smoke, like the smoke detector, and one specifically for detecting carbon monoxide. Every household ought to have both smoke and carbon monoxide detectors. In the United States, this is required by law in many places. However, there is a noticeable cost difference between these two devices. The combination carbon monoxide and smoke detector can cost about 3 times as much as a smoke detector alone. The lower cost of smoke detectors means that they ought to be placed in many locations around the home, especially in places where early detection of fire is important, such as bedrooms and living areas. Combination carbon monoxide and smoke detectors can be fewer in number, and they can be spaced out and placed closer to boilers, heating units, or other appliances that have a flame that may experience incomplete combustion. Both of these last about 10 years and should be included in every home. though always read the instructions when installing the detector, and professional installation is preferred. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, please visit us at our website, www.mechanical-y.com.